Okay, so this video is a continuation of the last video where I'm just doing a bunch of mole and mass stoichiometry problems. Okay, so we're going to stick with the same reaction. C3H8 plus 5 oxygen yields 3 carbon dioxide and 4 water. Okay, so next question says, how many moles of water, are produced when 88 grams of carbon dioxide is made? Okay, so we are asked to find moles of one substance and we are given grams of another. Okay, so we're going from grams of one substance to moles of another. So this will be a two-step problem. First, I will convert mass to moles using molar mass, and then I will go from moles to moles using ratio of coefficients. Okay? So the given information is 88.0 grams of carbon dioxide. Okay, first we have to convert grams to moles. So basically, if you do not have moles, convert to moles. Okay, the molar mass of carbon dioxide is 44 grams. Okay, so if I have 1 mole of carbon dioxide, it will have a mass of 44 grams. Okay, I got this number from the periodic table. 16 times 2 is 32, plus 12 is 44. Okay, grams cancels out. Multiply the numbers on the top, divide by the numbers on the bottom. You will get 2 moles of carbon dioxide. Okay, so I went mass to moles. Now I'm going to go moles to moles, and I will be done because the question asked for moles of water. So ratio of coefficients, I know I'm going to have moles over moles. Okay, I'm starting with moles of carbon dioxide, so I'll put moles of carbon dioxide on the bottom. I'm looking for moles of water, so I have moles of water on the top. The coefficient for water is 4. The coefficient for carbon dioxide is 3. So we're getting these numbers from their balanced equation. Now you are going to multiply the numbers on the top and divide by the numbers on the bottom. Remember, moles of carbon dioxide is canceling out. That's why we put it on the bottom. So you have 2 times 4 divided by 3. Okay, so 8 divided by 3, 2.67 for sig figs, and that is moles of water. Okay, so you get 2.666666, so I'm going to round that to 2.67 moles of water. Okay, and then we are done at that point because the question asked for moles. Okay, let's do one more example with this same chemical equation. Alright, so I did an example like this in the previous video, but this tends to be the one that students have the most difficulty with, so I wanted to do another example. So the question says, what mass of oxygen is needed when 88 grams of C3H8, which is propane, react? So we are going from mass of one substance, and you're asked to find the mass of another. Okay, so basically grams to grams. So we're going to have to do this in 3 steps. First, I have to convert my mass to moles, because if you don't have moles, you have to convert to moles. Then I'm going to use the ratio of coefficients to convert to moles of a different substance in the reaction, and then I will be able to convert that into the mass once I have the number of moles that are involved. Okay, so first step is write down the given. You're given 88 grams of C3H8. If you have grams of C3H8 on the top, you'll have grams of C3H8 on the bottom. Okay, The number that goes here is the number of grams in 1 mole of this substance. Okay, molar mass, the grams in 1 mole. It's always 1 mole for molar mass. Okay, and then if you add up the molar mass there, you have 3 carbon, so 3 times 12 is 36, plus 8, and you will get 44. Okay, so it looks kind of similar to the previous problem. So we have 2 moles of C3H8. Okay, 88 times 1 divided by 44. Okay, our next step is to use the ratio of coefficients. Moles over moles. You're starting with moles of C3H8, so I'll write that on the bottom. And we are looking for moles of oxygen, so I'll put moles of oxygen on the top. The coefficient for oxygen is 5 based on my balanced equation, and the coefficient for C3H8 is 1. Okay, so 2 times 5 equals 10 moles of oxygen. Okay, so if you go back to the graphic organizer, we have gone from mass to moles, from moles to moles of something else, and now we're going to convert that into grams. So I have 10 moles of oxygen. Okay, and in 1 mole of oxygen, we've got 32 grams of oxygen. Okay, so if I had a 32 gram sample of oxygen, that would be 1 mole, or 1 mole has a mass of 32 grams. And 10 times 32 is 320 grams of oxygen. Okay, and we already have the correct number of significant figures.